In example 2, we're asked to find the shaded area above. It's quite a complicated looking shaded area because you have a curve that's going right through the middle of it. However, we can break the shaded area up into two separate areas, A1 and A2. Because if you take the area A1, it actually lies between two limits on the y-axis. And then A2 actually lies between two limits on the x-axis. So that's the plan. We're going to get area A1 by integrating. We're going to get area A2 by integrating, and then add the two of them together. So let's start with A1. Now there's an immediate problem with A1 because at the minute we don't know what the limits on the y-axis are that this area lies between. So that's the first thing we've got to find. So we need the y limits, or limits on the y-axis. Now, in order to get those y limits, what we're going to have to do is take these x values down here and sub each of them into the curve. Because if you sub 1 here into the curve, then you'll be able to work out the y coordinate of this point, which will correspond to this y limit. If you then sub this x value here of 4 to the power 1/3 into the curve here, you'll work out the y coordinate of this particular point, which will then give us this y limit here. So in order to do that, we're going to have to sub x values into the curve. Okay, so let's start with our first x value, which is 1. So when x equals 1, sub it into the curve, y equals x cubed. So y is going to be 1 cubed, which is just going to give us 1. Okay, so we can immediately put that limit on the y-axis. Okay, so this point here has a y coordinate of 1. We're now going to chuck in 4 1/3 now into the curve. So when x equals 4 to the power of 1/3, y is going to equal 4 to the power of 1/3 all cubed. So we're using indices rules here. You're multiplying an inner power and an outer power, so that's just going to give you 4 to the power of 1, which is just going to give you 4. So we've now worked out the other limit. So the other limit here is just 4. So let's focus now on A1. Now because the limits are on the y-axis, we're going to use our different formula. So area is equal to the integral of a and b. These are our y limits, and it's going to be the curve to the immediate right of the area. Subtract the curve to the immediate left. And remember, we are integrating with respect to y because the limits are y limits. Now, we've got to make x the subject of the curve to the right and the curve to the left of the area. So let's take the curve to the left of the area. Well, the curve to the left of the area is just this vertical line, which is the y-axis, and that has the equation x equals 0. So x equals 0 is the curve to the left, where x is the subject. So we've got to do the same with the curve to the right. So the curve to the right of A1 is y equals x cubed. So we are going to have to rearrange that to make x the subject. So to get rid of the power 3 here, we're going to have to take the cube root. Now again, when you take a cube root, there's only one answer. Because a cube root is an odd root. If you take an even root, there'll be a plus or a minus, but when it's a cube root or any odd root, there's only one answer. So we've now made x the subject. So we're now ready to chuck everything in. So let's do that. So the area A is equal to our integral. Our limits are 1 and 4, remember. The curve to the right is the cube root of y. We're subtracting the curve to the left, which is just 0. And then we're integrating with respect to y. So let's tidy up. So we're integrating between 1 and 4. I'm going to write this without the root, so get rid of the root. That's the same as y to the power of a third dy. So now it's time to integrate. Again, we're using square brackets because we're integrating with limits, so add 1 to the power. So 1 plus a third is 1 and a third, which is 4 over 3. Divide by the new power, which is 4 over 3, and then add a constant. And then copy our limits down outside. Okay, dividing by 4 over 3 is the same as multiplying by 3/4. And now we're going to chuck our limits in. So break up the square brackets into 2 separate square brackets with a minus between them. So we're going to chuck the top limit into the integrated expression in the first square brackets. And then we're going to chuck the bottom limit into the integrated expression in the second square bracket. Now, 4 to the power of 4/3 is not going to be a nice whole answer. It's going to be a big stringy decimal. Cube root of 4 is obviously going to be a big decimal, and then you're raising it to the power of 4. So I'm just going to keep it exact. So I'm just going to keep it as 3/4 upon 4 to the power of 4/3. And then we're subtracting. 1 to the power of anything is just 1, so we're just left with 3/4 plus c. Again, the c's will cancel out, so you'll just be left with 3/4 times 4 to the power of 4/3, and we're subtracting 3/4. Again, what we could do is we could factorize this here. We could lift 3/4 out. So we're going to have 4 to the power of 4/3 minus 1. And that's going to be units squared. So quite a bit of working out to do there, but we've worked out area A1. So we've now got to do the same for area A2. So if we go back to our diagram, we've worked out area A1, now it's time to do A2. Now this one's slightly easier. The limits that the area lies between are now on the x-axis, so we're using our old formula. So area equals the integral between A and B. These are now the limits on the x-axis. Now, because the limits are on the x-axis, it's top minus bottom. And we are integrating with respect to x because the limits are x limits. So, let's have a quick look. Do we know what's on top of the area? Yes, y equals x cubed. Do we know what's underneath the area? Yes, we do. It's the x-axis, which is y equals 0. And do we know the limits? Yes, 1 and 4 to the power of a third. So we're good to go. So let's chuck everything in. So we're integrating between 1 and 4 to the power of a third. The top is just x cubed, and we are subtracting the bottom, which is just 0, y equals 0, and we're integrating with respect to x. Do you see the difference now? Again, we're integrating with respect to x, so everything in here must have x in it. So, tidy it up. We're integrating between 1 and 4 to the power of a third of x cubed. So we're good to integrate, so add 1 to the power, divide by the new power, and we're using square brackets because we're integrating with limits. So we're going to have x to the power of 4 all over 4 plus c, and then we put our limits outside. 4 to the power of a third, and then 1. Okay, let's tidy it up then. So we're going to break it up into two separate sets of square brackets with a minus between them. We're going to chuck the top limit into the integrated expression in the first square bracket. So we're going to have 4 to the power of a third all to the power of 4 over 4 plus c. And then chuck the bottom limit into the integrated expression into the second square bracket. So we're going to have 1 to the power of 4 all over 4 plus c. So tidy up. So first square bracket, there's an inner and an outer power, so we multiply those. So that's going to be a quarter upon 4 to the power of 4 thirds. Okay, plus c. And then we're subtracting 1 to the power of 4 is just 1, so that's going to give us 1 over 4 plus c. And again, the c's cancel out, so we're going to be left with 1 quarter upon 4 to the power of 4 thirds, and then we're subtracting a quarter. So again, what we can do then here is we could lift out a quarter, we could factorize it. So we're going to have a quarter upon 4 to the power of 4 thirds, and then minus 1. And that's going to be units squared. So again, keeping everything exact. So now let's get the overall area. So overall, A1 plus A2. So remember, A1 was 3/4, 4 to the power of 4 thirds minus 1, and then we're adding on 1 quarter upon 4 to the power of 4 thirds minus 1. Now, what we could do is we could multiply out each bracket. So we're going to have 3/4 upon 4 to the power of 4 thirds minus 3/4, and then we've got plus a quarter upon 4 to the power of 4 thirds, and then we're subtracting a quarter. Okay, let's tidy up. So we've got 3/4 of 4 to the power of 4 thirds plus 1/4 of 4 to the power of 4 thirds. So 3/4 plus 1/4 is just 1. So we're just going to be left with 4 to the power of 4 thirds. And then minus 3/4 minus another quarter is just going to be minus 1. So our answer is just going to be 4 to the power of 4 thirds minus 1. And that's going to be units squared. So that's going to be the overall area. If we flick back, that's going to be A1 plus A2 combined. Now, last bit, it talks about a ratio. It says in part B, find the ratio A1 to A2. So we need to set up this ratio A1 to A2. So part B, so A1 to A2. So we're going to sub in what A1 was and what A2 was into this ratio that is being set up. So A1 if we cast our minds back, was 3/4 upon 4 to the power of 4/3 minus 1. And then A2, which we just worked out recently, was 1/4 upon 4 to the power of 4/3 minus 1. Now, what we want to do is get this ratio in its simplest form. So what we could actually do here is divide through by the bracket. You notice the way the same bracket appears on each side of the ratio. So we could divide both sides by 4 to the power of 4/3 minus 1. So that means we'll be left with 3/4 to 1/4. What we could then do to get rid of the fractions is we could multiply both sides by 4. So obviously 4's cancel on left side, 4 cancels on right side, so we'll be left with 3 to 1. And that's a nice simple way to leave the ratio. So what does that mean? Well, it means area A1 is 3 times the size of area A2. And you can sort of see it in the diagram roughly. A1's a bit bigger than A2. It's 3 times the size of A2. So that would be our final answer there. That's the ratio of A1 to A2 in its simplest form.